All right, so we're going to get into logs and exponential functions. So, one quick thing I want to kind of teach you guys that I think makes this entire lesson easier because a lot of people have trouble with logs, and it is a very, very hard subject. But the best way to think of logs is it's the opposite of exponents. So let's say you have an exponent and it's the some number to the power x, and this is going to give us a y. So this is telling me that I have some number here. I'm going to multiply it by itself. So for example, if this b was a 3 and this x was a 2, it would be 3 times 3. If it was a 3 and this x was a 5, it'd be 3 times 3 times 3 times 3 times 3 again. So just for clarification's sake, this would be the same thing as saying, it'd be the same thing as saying 3 times 3 times 3 times 3 times 3 again, which ends up, let me just to give an example, just to make this easier to understand, 3 to the power of 5, that ends up being 243. So an easy way to think of exponents is it's the opposite. So here I have a b, I have my x, and I have my output, my y. Another way of saying this would be to say log base b to the y of the y. So this is what's known as an argument. So log base b of this argument, this y, will give us an x. So in other words, if I said log base 3, so notice how this is the base on both of them. Log base 3 of 243, we'll get a 5. Now, some calculators do have the ability to put this in here. Most of them don't. So another way to write this would be log of 243 divided by log of 3. There's a reason for this, but we'll get into that later, is also equal to 5. So these two things, these two different boxes right here are the same thing. They're just written differently, and they're written differently for a different reason. This is log base 10, but this is the easiest way to plug something into your calculator. So whenever I'm showing the work, it'll show like this. Now, just to show you guys, I'm going to use Desmos just to prove it, just to kind of get you guys used to these exponents. Um, so let me get into that. So here, if we go to Desmos, the scientific calculator, we see this log base 10. And I believe there is a way to do the little base, but we won't get into that right now. So first off, I'm going to start by hitting the division sign on my keyboard. That makes this fraction. And I'm going to say the big number goes first. Then I'm going to do my small number. I could have pushed log, but I can also type it in. Desmos is actually pretty smart that way. And you see here that I get that 5. So that's all this is saying. This is saying it's the opposite of saying 3 to the 5 gives us, let me use a different color. It's the opposite of saying 3 to the 5 gives us 243. It's saying like, oh, if how many times do I have to multiply this 3 to get 243? So this is just a different way to figure things out backwards. If you go into like computer programming, you'll probably be familiar with log base 2, because if you've ever noticed when you're talking about storage, it's always like 512 storage and things like that. This is because computers operates in zeros and ones. So it's like 2 times 2 times 2 times 2. Eventually you'll get this 512. So moving on, let's see how Edmentum goes about teaching this. But this is one thing that I think is the most useful. If you can master and understand this, it makes the rest of learning about logs and exponents so much easier. All right, so moving on, let's get started here. All right, so we're going to do a warm-up exercise. So this says solve this equation. To do so, you'll need to use the left side of the y, right side, open the graphing tool. Oh, I see what they're making us do here. Oh, interesting. But we actually won't have to try that hard. So one of the benefits here is our log is a 10. So solve this graphing. To do so, use the left side and the right side. So they want us to do this. So I'll show you how to do this. So you can use the graphing tool. I prefer to use Edmentum. So they're going to show us how to do this, solve this by graphing. So they want us to do this. Y equals 5.13 10 to the 2.3x, and they want us to make another graph where it's y equals 400. This is really easy to do with Desmos, so I'm going to go to Desmos right now. Go to my, actually I can just do this, graphing calculator, and we're just going to do y equals 400. And then I'm going to zoom out here so I can see where y equals 400. So I have to zoom out a lot. I'm using the wheel on my mouse. You guys can use this little minus. Ooh, actually, that would have been a lot better because it did it a lot faster. And the next thing we have to do is do the other equation, which is a lot harder to type in. Y equals 5.13 parentheses 10. And then I'm going to shift 6. Shift 6 puts that little caret, that's the exponent button, and the 2.3x. So that should be it right there. Now, the interesting part here is you can't really see it, but it is an exponential. We just have to zoom in a lot to actually see it. So let me go back down here. You can see that there is exponential growth. It's just since it's base 10, by the time it gets to 1, it's like super high up. So, and that's because think of it this way. We're multiplying this 10 by itself. If we plug in 1 for x, we're multiplying it by itself 2.3 times. That means 10 times 10 times 10 to the 0.3. So it's at least 100. So it's a lot. So that's why it's growing so fast. And that was just for 1. If we do it for 2, it's going to be even more than that. It's going to be like 100 times more than that. So we can get into that later. But for right now, all we need to do is see where these two connect. So if we go to where they connect, oops, accidentally hit the back button on my mouse. I can just click right here, and Desmos does a really good job of finding it. So our answer is going to be 0.823. So right there, I can just type in 0.823. Hit submit. The one thing I don't like is they're like, use this tool. And it's like, all right, but you didn't tell me how to use the tool. You actually have to go, if you want to use their tool instead of Desmos, you have to go to Math Tools and Graph. So that's how you have to do this when you're using the graphing tool. They really should have put a link to it. But I recommend Desmos. I just think it's a better tool. So let's move on to the next one. So this is just talking about an exponential equation, meaning that there's usually an exponent here. E is actually a number. It's a very weird number that occurs a lot in math. It's been a while since I've studied E. I think we will actually have to study it later. There's a story for it. It occurs a lot in nature. So it is a number that exists a lot in nature. And logarithms are kind of the way to just do powers backwards. So their definition for logarithm is a quantity representing the power to which a fixed number must be raised to produce another number. In other words, it's saying like, hey, this log tells us how much this b, how many times we have to represent this b to get this x. So it's saying, in other words, it's saying what the y is. What power will it take? What will, oh, sorry, I wrote it backwards. This is supposed to be a y. What power will it take to get to that y? This was y. So this log represents the power it takes to get to this y right here. All right, so let's carry on. That's a very weird definition, which I feel like would be hard to understand. Again, watch these videos. They're really helpful. And explaining why we need them in real life. So scientists use this all the time um, to help you do things. It also helps, like, if you're curious, this can also help you figure out how much money it costs you to be in debt. So whenever you have like an interest, like whenever you're borrowing money, like let's say you're borrowing for a car loan, there is a interest that's happens repeatedly over and over again. So it does cost a lot of money to be in debt, and these formulas show you like how much. I think we'll have examples for it. So we're going to learn about properties of logarithms. So remember when we did exponents, like if we had something like a to the 2 times a to the 3, that equals like a to the 5 because we're adding them. Logs also have these properties. So this is something you definitely want to like study up on when you're doing this unit. So again, the base is this little b. I don't think they give you the name. They don't give you the name for the argument. That's very weird. So, but that's your argument. All right, so let's carry on here. So when we're talking about this, this is actually like a quick summary of what I did at the start of the video, explaining it a little bit more. So what we're going to do here, so this is just saying like another way to write a log. Instead of writing it log base 3 of 9 equals x, it's saying 3 to the x equals 9. So this is a good way to kind of start learning how to do this. They're probably not going to get into that little trick where I say log of 8 over log of 2 for a while. They're going to break it down a little bit more. They're going to say like, well, why don't you just write this 16? 16 is the same thing as 2 to the 4th. So if you're doing log base 2 of 16, then your x has to be 4 because 16 is the same thing as 2 to the 4th. So if you have log base 10, and what's interesting about this, they're just doing this for your benefit. Normally, you never write this log base 10. It's the same thing as just saying log. Whenever we're talking about logs and you don't see a base, it's assumed that that base is 10. So if I said log of 100, it'll say 2 because it's assuming base 10. So log of 100, there you go, it's 2. So it's just saying whenever you see this log, so if you see log of 100, it's the same thing as saying log base 2 of base 10. 10. Oh my gosh. Base 10 of 100. They're all equal. They're both equal to 2 because they're the same thing. So that's all they're really saying here is just master how to think about this. Whenever you see a log, don't panic. All you have to do is just rewrite it as an exponent, and usually that in and of itself makes it a lot easier to understand. So the next one, log base 5 of 125. That's the same thing as saying 5x equals 125. So what they're doing here is they're like, well, if you have 5 to the x is equal to 125, and we know that 125 is 5 to the third. I only know because I've practiced this a bunch of times. I don't know how they expect you to do it. I guess they want you to just be like, all right, let's get a calculator out. Let's do 5 times 5. All right, cool. That's giving us 25. So far we've 2 5s. Then we do times 5 again. We use 3 5s. So that's pretty much how you're going to have to solve these until you get some practice in. It took me a long time to get practice in to kind of recognize some of these. So let's get into the properties of logarithms. So one of the cool things about the properties of logs is, well, remember when I just said it, but remember this property? It allowed us to add the powers. Well, think of it this way. If logs are the opposite of exponents, that means if you're adding logs with the same base, that's the key part here, with the same base, that means you can just multiply your arguments. So anytime you're adding stuff, you can just multiply the arguments. So you can see that right here. It says that if you're adding 2 logs, you can just multiply the arguments, or vice versa. If you're multiplying 2 things, you can just separate it into 2 logs with the same base, of course. So same thing with division. Remember how we had something like this? Let me erase this right now. Remember with exponents, we had b to the 8 over b to the second. We ended up getting b to the 8 minus 2. Same thing here. If you're dividing, you can split up into subtracting, or vice versa. If you're subtracting, you can turn it into division. And they give you a nice little example here to go over. All right, so going into this next one. So log base b of this. This is what's known as a power rule. I don't think there was so much of an equivalence here with exponent. Well, there kind of is, but I think it would be more confusing if I were to explain it. Basically, this says if you're multiplying a log, that's the same thing as raising your argument, this little m right here, to that power. So it's just saying like, hey, you can just grab this and move it over here, write it as this, and it's the same thing. And the reason why that is because log represents a power. So if you're multiplying a power, then why not just multiply the power over here? It's a little more complicated than that, but that's the easiest way I can kind of explain it right now. And obviously, if you have 2 logs that are equal to each other and have the same base, then that must mean those 2 arguments, the m and the n in this case, must be the same. So if I have something like log base 2 of 8 equals log base 2 of x, this tells me that this x must be 8. Without even having to solve this, since both of the bases are the same and they're equal to each other, this x has to be this 8. There's nothing else it can be. And that's because log is what's known as a one-to-one function. Every x has exactly one y. Every y has exactly one x. And because of that, if these logs are the same, they have to equal the same thing. All right, I was hoping to get into actual practice, but I'm looking at my time and I'm running low. So just keep in mind, rewriting it is going to help you understand the properties a lot better. And next video, we'll start off with this lesson activity. So just, I know it's kind of disappointing that I only really answered one thing for you guys, but keep that in mind and really try to understand and go back and watch this until I release the next video that'll go over more of the practices instead of the ideas behind it.